As an executive, you may have multiple machine learning projects in your backlog. That backlog is only going to grow as these projects become more and more popular. We all want to make an impact and get to deployment, but we also want to make sure that we're being financially responsible. The existing rules of return on investment, or ROI, still apply to data science projects, they just have their own little twists. In this video, I'm going to share with you some of the questions that I asked for stakeholders when I want to look at the return on investment on a model. Welcome back, I'm Dennis and I'm a chief data scientist with more than 20 years of experience working with companies all around the world. Having exploratory conversations before you commit to a project with your stakeholders can help you understand a lot about the items that you're going to need to develop the ROI calculations. Having these conversations with your colleagues also serves an opportunity for you to help educate them on the data science lifecycle. When we look at the ROI items from the business perspective, it can also help you to make some inferences for other items that you're going to need during the life cycle. I'll leave it to you to fill in your own dollar values. I'm just presenting the framework that I have used in the past and during these conversations. Generally speaking, when I sit down with my stakeholders, I want to know a few things. Where is the data and in what format? How often will the model be used and by how many people when it's in its deployed state? How many people from the team are available from human validation? What hardware resources are needed for the model? And what is the project management overhead that the model will create? So the first thing I want to know is, where is the data and in what format? Can the data be obtained programmatically, or is there a lot of manual processing that still goes into that data? Email, believe it or not, still remains as the world's most popular workflow tool. It's shocking the number of reports and pieces of data that come in via email or other means that are just don't lend themselves to being quickly ingested into your training cycles. So how quickly can the existing data reach a state where it can be used for training? These are really important questions to establish the early stages of your project. Is it already structured, or are you going to have to also write custom code to format and transform the data? Now, of course, here I'm just talking about data engineering tasks with traditional programming, where we really haven't gotten to the data science parts of it yet. And that's okay. These are still tasks that are going to fall onto your team and should be part of your overall ROI calculation. For the next portion, you should lead your stakeholder down the road to think about what they will do with the model once it's deployed. How often will the model be used? How many people will be using the model? These questions can help with your traditional ROI baseline items for things like human hours saved. You're going to want to do that for most projects. But here's what we're really trying to ask. We're really trying to make a couple inferences about their data and about their project. For example, if they tell you that this is a model that will be used on a quarterly basis to address some sort of quarterly reporting, then you have to ask, well, is there enough data? A process that only happens 4 times a year simply may not have enough data in its backlog for your own training. In another instance, you can also think about whether this is a project that's being raised because of enthusiasm towards data science and everybody wants to have a data science project, or is it just a process that the team can bear and is ultimately better handled by humans? That's also possible. So by asking how often the model will be used, you can make some inferences that are going to help you with those questions. Finally, it's always helpful to know the human hours that your projects can be associated with. That's a key performance indicator that you're going to want to track on your own back end for the overall hours saved that your models can be credited with. Here's the next item I like to ask, and it's a big one. How many people from the stakeholder team that know the data and know the model are going to be available for human validation? That's a very critical question to ask because it's a big part of the process during algorithm development. It simply shouldn't fall upon your team to do that alone. They just don't know the answers best. Your stakeholders are going to do that best. Let the business make the decision on what the model should look like. It also allows stakeholders to have a little bit of skin in the game, if you will. It lets them play a role in shaping what the final deployment actually looks like. When having initial discussions with your stakeholders, you must make it clear that the overall project process will slow down significantly or even come to a stop if you can't get feedback from their team. They simply have to be part of the process. If they tell you that they want to take a hands-off approach or not going to have a lot of people, then this might be a red flag you want to address early on in these discussions. Also emphasize that some models will require more human validation than others. For example, a natural language processing model or an image processing model is going to require a much bigger time investment than other types of models. There's really no fast way to validate NLP results. The results simply have to be read through by human eyes. Now let's talk about hardware. There is still a massive difference in both availability and costs between CPUs and GPUs. While virtually all models can benefit from GPU training, it may be overkill in some cases. The good news is that many models can still be successfully trained on CPUs. This is especially true if it's traditional machine learning, and you can leave the AI-based models for the GPUs. The training costs should be straightforward for you to find based on your own internal billing or your cloud provider billing. And you should also consider if this is a model or a project that will start on CPU but will eventually need GPU based on additional data or other phases of the project. That can make your costs balloon over time and should be taken account during your initial projections. Finally, what is the overhead that your model will create from a project management perspective? Every model needs maintenance over time, and this is going to fall directly on your team. The number of projects and algorithms that your team is maintaining was only going to grow over time. It's kind of a one-way street that way. You have to be careful with this because it can lead to a situation where your team does a lot more maintenance than new development. You should also ask about change control and model review management. If these are items that are required within your organization, that adds to the overall workload from your team too. Your stakeholder really isn't going to play a role in that. That's really on you. You should also ask about how often new data will be available. This is going to affect the training cycles that you need to do and how often you're going to have to go through that change control and the model review management. By looking at the new data, you can also infer some of the growth that your algorithm is going to go through. While file size usually isn't a concern for most models, the speed at runtime, the speed of the predictions at runtime, may be affected as the model grows and is trained on additional data. Finally, there's also a direct cost for each of the training cycles in regards to how long are they going to take. Are we talking about training cycles that take a few hours or a few days? That's a time investment on your team that you also need to take into your calculations. I hope you found this helpful, and I'll see you next time.